Okay, now members, let us see how we handle this question. We are still in vertical motion. The particle of mass 4 kilograms is suspended, so we read as we summarize there. So our mass is 4 kilograms from a fixed point C by a light out string of length. So we are giving us our length of the string as 15 meters. When the particle is hanging freely in equilibrium, its horizontal speed, they are giving us u as 21 meters per second. Find the tension in the string if the angle between the string and the downward vertical is 60. So this is the case we are having. We have a string, then they are supporting a particle. So this is the downward vertical. But now they are telling us that the angle from the downward vertical is 60. So if I try to do that, this is going to be now. If I consider this to be the fixed point, of course it's going to be the center of the circular path as I try to in this form. So is that the center is going to be where this string is fixed. So from there, they are telling me that the angle here is 60 degrees. So here I have 60 degrees. Of course, note that the length of the string is going to be equal to the radius. It's going to be equal to 15 meters. So here I'm going to be having 15 meters from up there, and also here I'm going to be having 15 meters because from the center of the circumference, the radius, and the same there. So now from here, I'm going to separate this, and now my weight is going to be here. I mean my particle. Of course, it's going to exert the weight of the mass times g. Then this angle here is going to be the same also as that angle 60. So you try to resolve this weight, we are going to be having this as 4g cos 60 degrees, and then this horizontal component here is going to be 4g sine 60 degrees. Of course, from there, we shall be telling us that this velocity here, the u, from here, our u is 21 meters per second. Now, we shall be having also a height moved by this particle from here. It's going to be our height moved by that particle. Okay, so now, if we try to resolve like that, that always using Newton's second law of motion, the force is going to be equal to this. Now, what is our resultant force? We get now the tension in the string. Of course, this string is going to be having tension in that order. So, it's going to be the resultant along the radius is going to be this minus that. So, we have t minus 4g, then cos of 60 degrees equaling to the mass, which is 4. Times acceleration of a circular path is v squared over r. So is that always, by doing that, our cos 60 is always a half. So we have t minus 4d now times a half equaling 4 times v squared over our r is 15. If I simplify this, I have t minus 2d equaling to 4 over 15 v squared. You see, I need v to get, because this is known, I need to get the tension, but I need to get v first. So I call this equation 1. So now, allow me to consider this only. So consider, I think you know what the name we give to this. This is called a sector. Consider this sector here. That's the sector I'm going to consider there. So, I'm interested in getting this height, h. Of course, you know this is our center. So, from here up to here, you have 15 meters, up down here. And so here you have also 15 meters because it's the radius there and radius there. Now, this angle here is 60 degrees. This is perpendicular, of course. Now, you see if I have this length and I have this angle, then this height from here up to here is going to be 15. It's going to be 15 cos 60 degrees from here up to here. So now I can aggregate h because I know from here up to here is 15 and from here up to here is that. So I can get h with ease. So my h you see is going to be now 15 then minus 15 cos 60. So my h is going to be 15 minus then times, which is going to give me 7.5 meter. So I have my h. Why am I going to use my h? Now, meaning if I use the third equation of motion, v squared equal to u squared plus 2as. You start now our particle is going in that direction. What does it mean? So that means that our acceleration is negative v because it is moving upwards. So it's against gravity, and the distance it has covered from here up to here. Because when it's here, it has covered that distance. So our s, because these are equations of motion in linear, so the line linear from here up to here. So our s is going to be equal to our h. So substituting there, and this is now our velocity they gave us at this point, the horizontal velocity here, they gave us u as 21 meters per second. So my v squared is going to be now 21 squared minus 2dh. Okay, my v squared is going to be now 21 squared minus 2 times 9.8 times 7.5. And so I'm interested in getting v squared. So which I want there. So I'm going to get I'm getting 294. So now I call this equation 2. And I'm going to come here and I say put 2 in 1. Put 2 in 1. So I put R1 is 2d equaling 4 over 15 v squared. This would be t, and that's 2d equaling 4 over 15, now times RV, which is 294. So that now, when I take this side, I have my t as 4 times 294, now over 15, now plus 2 times this b, 9.8. And from there, my answer is going to be 98 newtons with ease. So that's the tension in R3. Now, here, because we saw in the previous lessons that always our H is equal to R into 1 minus cos theta. And so that our V squared is U squared minus 2B R1 minus cos theta. So if you know this, you just press them and then you put in the values, you see. That's what we are having. This is common and factorize it out. So those are the things we have been using. Then this one is going to help you get your I think you see from here if you substitute their H. So it's up to you. Either use that because those are exactly from there where we go, but there we consider the idea when we have theta, R, and so on. So anyway, that's the idea. I wish you well.